Hi guys, here is your constructing polynomials Desmos instructions. All right, for the first slide, these are your 3 minimal requirements that you are going to sketch for your polynomials. So this one I'm gonna follow along with you. All right, so again, minimal, you can add more to this after you draw these first 3 requirements. So on the left hand side for number 1, as x approaches negative infinity, your y value approaches negative infinity. On the right hand side, number 2, as x approaches positive infinity, your y values approach negative infinity. So just your end behavior alone, you should know that this is an even degree polynomial. So that means that your leading exponent is even, or your factors exponents added up should equal an even number. All right, because they end in the same direction. Okay, and then requirement number 3 is that x equals 4. So there we go. So you can fill in any multiplicities, any other roots that you would like in between, just as long as these are your end behaviors and your graph passes through x equals 4. Okay. The second screen, you're going to let Desmos graph it for you. So instead of you writing or sketching it out yourself, you're going to click on these options right here. All right, so the most obvious one is your one root is x equals 4. So if you were to return this so that it is set equal to 0, your factor would look like this. All right, so your end behavior is negative, so you have to choose one of your coefficients, which coefficient makes sense so that it ends negative. All right, so you're going to choose one of those, and then here you're going to make your degree an even number. So again, your exponent that you don't have to write is 1 for this, similar to the one before it, after it, and so forth and so on. You want an even degree, so you want it to end in the same direction versus opposite directions. All right, so this has a degree of 3, because if you add all of those exponents up, it would be an odd number. So you can choose between 3 to 5 here in this section. All right. Slide 3. Here you are just going to replace one of these numbers. Obviously, you can't replace this x minus 4 because it is one of the required roots. But what else can you change, or what else can you add to it so that you still maintain the end behavior, and your root at x equals 4? So change a number, you can add numbers, you can add multiplicities. All right, so that's what you're doing here. Slide 4, sketch 2. Again, your minimal requirements and behavior. Here, when x is 4, it has a multiplicity of 2, so here I should see a bounce. All right. All right, so you guys fill in between, and behavior, you can go through other points, but it needs to have a bounce at x equals 4. Slide 5. So Desmos is going to build it for you. Pick and choose your options that you would like. Again, the minimal one should be your x minus 4. It has a multiplicity of 2, so there should be 2 of those. All right, there should be at least 2 of those. And then here, your minimal is 3 to 5 options again. All right. Slide number 6. Here, your requirements are that they have opposite end behaviors. So on the left side, it ends positive. On the right side, it ends negative. That means it has an odd degree. So if you were to add all of these exponents up for each of these factors, it should be an odd number. All right. So the second one, if you add all of the exponents up, this second one is not an option, because if you add the exponents, that's 2, and that's even. So the second one would not be an option. All right, so it has a root at x equals 5. So set each set of parentheses and set it equal to 0 and solve for x and see if it equals 5. Obviously, these ones with the 3's do not equal 5, and the ones with the 1 does not equal 5. So you're testing the ones here so to see if there is any of them that gives you x equals 5. All right, so there are two options. There's two answers on this page. Okay. All right. Slide 7. Here for requirement 1, where the leading term, this is your leading term in standard form. Okay. So do not be confused by factored form. This is in standard form. That means that this has a degree of 4. So that means it has 4 x-intercepts or x-zeros or x-roots. So here it tells us in requirement 2 that it has 4 real roots. Makes sense. It's raised to the 4th power, has 4 real roots. They give you 2 of them. So it has one at x equals 2 and one at x is negative 1. All right. So it has a degree of 4. It has a positive, it's positive coefficient. All right. Positive leading coefficient. So that means that it should be ending up, up, because it's even, so they should end in the same direction. All right, so you guys fill in the in between. Okay, slide 8. Let Desmos build it. So there is your leading coefficient. So here you're going to select all that apply. All right, your leading term is a 5. So notice that all of your x values here, their leading coefficient is 1. So you need a 5. All right. X equals 2, so that should be the minus 2. X equals negative 1, so that should be a positive 1. All right, so here your degree with just these 2 factors is 2. You want a degree of 4, so go ahead, select all that apply. Okay, going on. All right, number 9. So here you're going to change one or more numbers so that it still meets these requirements. Okay. So you can change one of the intercepts that you do not need. You can add a multiplicity just as long as all of your exponents added up equal an even number. All right. It has to have 4. All right, 4 real roots. So here, if you were to add another root, you have to take one of the ones that you don't need. Okay, so you're replacing. All right, so you only need to make one change at the least. If you can find something else that better suits the same criteria for 1, 2, 3, go ahead, see what you can come up with. All right, slide 10. All right, so same thing, leading coefficient. Leading term is 2x raised to the 5th power. So that means that the 5th power, this has 5 roots. All right, so there should be 5 x-intercepts. Now, number 2, your requirement for number 2, it says that it's non-real complex roots. So complex roots means that they're going to be imaginary numbers. So that means that whatever your root is, you're going to take a square root of a negative number. All right. So here for this particular screen, what might be helpful is actually if you move on to the next slide and then go back and redraw what you get from slide number 11. All right. What do I mean by that? Here are some examples. Now, if you set each one of these factors equal to 0, do you get an imaginary root? So like for instance, the first one that I can't write on, x squared plus 1 equals 0, x squared equals negative 1. Oh look, you're going to take the square root of both sides, so the square root of a negative 1 is a complex root. It has an I in it. All right, so that's what it means. Okay. Number 12. Here you're just going to change one number, see if how that, ooh, excuse me, what you can change so that it still makes sense. What might be helpful is if you guys open another tab and go to desmos.com/calculator and actually graph it if it does not change your graph for you, okay? And then the last slide, you are just going to match the cards, all right? So you can click on the card and hold it if you wanted to zoom in, all right? Here I have a root at -1, 1, and 2. So that means I have 3 terms. If I see any of them here, oh, I don't think so. Has a root, okay, negative infinity, positive, no, there's something else. It's in here. All right, so it might not be your root. So it has a root at x equals 3. Maybe I should just look at all of them. X equals 3. Oh, here we go. That goes with that. Look at that. Oh, it has to go in there and then move it around. All right, so see how you guys match the cards. If you need any help, let me know. All right, you guys have a good day. Bye.